I really do feel for people in GA that are maintaining that aging fleet, particularly where they're up against the rising costs. The operational costs of these aircraft continue to go up. These aircraft that we maintain, you sometimes have to have a less than commercial approach. It's the museum here is dedicated to preserving these aircraft because they're a very important part of history. I don't think there was anyone that ever went out with a business plan and said, I've got a great idea, let's start a museum, we're going to make a lot of money. It doesn't work that way. And of course, flying the aircraft and keeping these aircraft operational, drive the costs up exponentially. With aging aircraft, there's probably a few lessons out there. And aging aircraft, I haven't been in GA now for 15 years, and so all of the aircraft that I used to work on are still around. They're just 15 years older. The lessons are probably the same as to the way we operate our airplanes here. And you need to know your airplane. You need to know it back to front. You need to understand, on a deeper level, you or your engineering company needs to understand what the airplane's made out of. If they're as old as aircraft like the Spitfire or the Ryan or the Tiger Moth, you need to understand what the materials are. You need to understand, what the lifespan of those materials are. If they were made out of, some of the more what's called magic metals, some of the different alloys that appeared, throughout the 1950s and 60s and 70s, and you need to be in tune with other operators, and that's one of the main things. Look out there and see what other problems people are finding. If other operators are finding problems with castings, or forgings that are made out of a particular material, you need to probably think about, although it may not apply at the moment to your airplane, but you need to start thinking about, well, that material has had a problem. That metal was made, during this time period. I've got my airplane, it has that material in it. We should start looking long term to see if whether or not, that material is also going to have an issue.
As aeroplanes age, as maintainers, we have to be more proactive. We need to change our focus to what's going on with the aeroplane that we can't see, which is purely age related. And that's where employing modern technologies really assists us in data logging to soap samples through to non-destructive testing. The beauty of data logging is we get factual information which we can compare to 5 years ago, 10 years ago, and just draw direct comparisons and see whether we are seeing a trend, a change, or an impending problem. We also use spectro oil analysis programs where we take oil samples at regular intervals and we have it analysed, and it will bring up or show up whether we're starting to see metals, what type of metal it is, our oils, the condition of our oils, whether it's starting to get moisture content, whether it's becoming acidic. We employ many varied different techniques to non-destructive testing. We do fluoro dye pen, have contractors for X-ray inspections, eddy current. As these metals are aging, surface corrosion, that sort of thing, is not your only enemy. You're starting to see intergranular corrosion, which isn't always evident to the naked eye. So we do have to employ the services of contractors with advanced technology to ensure the ongoing airworthiness of the aeroplanes.
The biggest tip I could give for people buying an older airplane, and this is coming out of my GA background, is that if you use the example of a Beechcraft Baron, I think the Baron is still in production, and currently that aircraft is around the $1 million mark. And for people, when they go out and look at a Baron, they might find a reasonable time one that's made in the mid-70s, for example, and they can get it for $180,000 or $200,000. And although that sounds like quite a bargain, what they have to remember is that when they roll that aircraft in and out of the shop, the spare parts schedules are set around that $1 million price point. The labor required to maintain that airplane is actually going to be the same cost per hour as what that $1 million airplane would be. So you're going to be paying a high labor rate. But you're maintaining an older airplane, so you might actually end up needing a lot more hours spent in order to keep your airplane in reasonable condition. People will go out and buy, one of these aircraft. A Cessna 182 is another example. I think a new one is about $500,000. You'll see people go out and buy a $50,000, $60,000, $70,000 Cessna 182, forgetting quite quickly that if they need a new aileron or they need some sort of component from Cessna, they're buying parts which are based around the current cost structures of a brand new airplane. So it's easy to get trapped into thinking you're going to buy a cheap airplane, but maintenance over the long run, certainly the newer airplane that you can buy, the better, but certainly buy one that is in very good condition. In terms of operating the aircraft, the manufacturers never believed that these airplanes would be going 50, 60, 70 years down the track. The aircraft behind me is a Supermarine Spitfire. When it was built, they desperately hoped, it would only be needed for a few months. That doesn't mean it wasn't very well made. It was built using the best processes and the best technologies of the day. What that does mean is that we believe that with careful application of data, perhaps some modern inspection techniques, and careful maintenance practices, you can continue to maintain these aircraft. They are made out of what we consider to be modern materials, and we think they will go for a long period of time, but you are going to have to spend money on them. That's all there is to it. You're going to have to pay very close attention to what's going on in your engine, in your power plant, in your propeller, in your airframe and in your structure. And we've learned over the years that sometimes things need to be resparred. The Spitfire behind us here, the former owner, when he rebuilt it, he did an inspection of the wing spars and felt that it needed to be resparred. And so he had new spars manufactured at a very high cost and put those new wing spars in. And that is the penalty that you have to pay if you want to operate an old aircraft. Over the long run, I do believe that these airframes, these engines, these propellers, that they can be operated for a very, very long time. But it's going to cost more money. Once an airplane begins to wear out and begins to age, all of these issues can be addressed, and we've proven that, with flying beautiful airplanes like the Spitfire for as long as this airplane's been flying. We've proven that you can address those issues, but it certainly does come at a cost.